video, we're going to take a look at another question on undefined and vanishing fractions. Actually I said another question because I already did a video on this same topic before, and I solved some questions. So I just decided to solve this set of questions on the same topic again. So let's see this question now. If y equals this, for what value of x is y not defined? What does that mean? For what value of x makes y undefined? That's just a simple interpretation. What value of x makes y undefined? And this means 5x plus 4, this fraction, this equals y equals undefined. That's the meaning. So we can simply say 5x plus 4 over 2x plus 3 equals undefined. So that's it. So we have something like, for this expression to be undefined, then the denominator 2x plus 3 must be equal to 0. So then we have 2x equals minus 3. And we divide both sides by 2. We have our x to be negative 3 over 2. So negative 3 over 2 is the value of x that will make y equals undefined. Let's see another question. The second question actually, that determine the value of x for which y vanishes. So for y to vanish, it means y equals 0. So when y equals 0, y is said to vanish. So when we have 5x plus 4 equals 2x plus 3 equals to y, but y is equal to 0. So it means 5x plus 4 over 2x plus 3 equals 0. And for this fraction to be equal to 0, the numerator, its numerator 5x plus 4 must be equal to 0. Why is it like that? This is because 0 over anything is 0. So then we have 5x to be negative 4, and divide both sides by 5. We have our x to be negative 4 over 5. So that's it. So y vanishes when x equals this value. Now let's see the last question we have here. The question is, for what range of values of x is y greater than 3? If y is greater than 3, definitely 5x plus 4 over 2x plus 3 must also be greater than 3. Why is it like that? This is because anything that happens to y must also happen to this expression here, because so as to maintain the equality sign between them. So if I multiply this guy with 2, I must also multiply this guy with 2. So in this case, if y is greater than 3, this expression must also be greater than 3. So that's it. So we say multiply. We solve this one in the inequality way. So multiply both sides by 2x plus 3 squared. Why squared? Why squared? This is because we are very certain that the square of any number is positive. So we can't multiply both sides with 2x plus 3. This is because 2x plus 3 could be negative, and that will alter the inequality sign, because if 2 is less than 9, then negative 2 is not also less than 9, but what? Greater than negative 9 rather. So that's it. So, and why is it like that? It means whenever we multiply negative with both sides of an inequality, or we divide them by negative, what do we have? We have the inequality sign to be changed. So that's it. So it's best that we maintain the inequality sign, and the only way we can maintain the inequality sign is by multiplying both sides with a positive number. So that's why I did this. So we have 5x plus 4 over 2x plus 3 multiply with 2x plus 3 whole squared. We have it greater than 2x plus 3 whole squared. Now we have 5x plus 4, 2x plus 3. This cancels this. we have 2x plus 3 all squared. We have this negative minus, I can bring this to the other side, greater than 0. I could factorize, then I have this something like this. 3 multiplied with this, we have 6, then we have 9 greater than 0. We have 2x multiplied with this, and after all, when 5x subtracted from negative 6x, we have negative x, then we have this greater than 0. So we could get the critical values of x from this particular guy, but we could factorize also negative x, negative 1, then we are left with something like this. So we could get the critical values of x. So critical values of x, instead of I will make 2x plus 3. You can use this. This kind of explains it better. Make it equals 0 to get the critical values of x. What are the critical values of x? These are the values that cuts the x-axis. The values that cut the x-axis of the graph. So that's it. So let's go to it. So we have 2x plus 3 to be 0, or negative x minus 5 to be 0. So therefore our x is negative 3 over 2 or negative 5. So that's it. So this inequality actually, so we need it in form of range. These are just the critical values. Equals negative 3 over 2. Critical values of x equals this, or negative 5. So we go back to this. We use our sign table method. So we use our sign table method. So using the sign table method for that equation, the equation we have actually is negative 2x plus 3, then x plus 5 to be greater than 0. This is what we have. So we use the sign table method to solve this. So you have to be familiar with this particular method. My next I'm going to do a video that will explain this better, and whereby I will be using the graphical method also. So that's it. So let's see, this is greater than 0. So from let's draw just the x-axis out. We have this point to be 0 from negative infinity to positive infinity. We have the two values of x to be negative 3 over 2 or this. So negative 5 is here, somewhere here. We could have negative 6, then negative 6, like that, negative 7. Then negative 3 over 2 is somewhere here also. So that's it. So this, this is equivalent to negative 1.5. So 0, negative 1. So 0, negative 1, 1.5. I could have 2, negative 2, like that, negative 3, negative 4, like that. Just trying to show you the values. 1, we have 2, 3, 4. So we have negative first. So we could write the negative 1 here. Actually the negative 1 means something like negative x raised to the power of 0, or something like that. So everything is negative, 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 negative. Then we have 2 plus x, this. Then we have x plus 5. Then we have 2x plus 3. We purposely did this because the sign must be there. Anything we do, this negative can't leave. When we divide it by negative, the sign changes. When we multiply it by negative, the sign changes also. So it must be considered. So this is the first value we have, minus 3 over 2. This, we have this. Then we also have minus 5. This is another value. So values of x that are behind -5 are less than it. So consider that first, because the two values has actually cut the graph into two, the x-axis into three, rather. One part, this is the first part, second part, then the third part. So that's it. So negative x is less than -5, and -5 for this particular region, -5 is less than x and also less than -3/2. But these other values that are here, they are greater than -3/2. So something like that. So we have when we pick any value that is less than -5 here, for example -6, we put it here, we have a negative answer. So we actually deal with the sign. That's why we call it the sign table method. So we deal with the sign, not the number, the answer we get. So, or not the constants we get together with it. So when we pick any value that is between -5 and -3/2, for example -2, we have the negative sign also. We have the negative answer. -2 times 2, we have -4, plus 3, we have -1. So we don't really care about the 1, so we care about the sign. So when we do that for this, any value greater than -3/2, for example like 1, so we have positive. Then here also the same value we tried for this, we could put it here, then we have the same thing, then something like this. So when we multiply these signs together, we have this, then we have this. So always note that we can only have one positive answer, and is that positive, negative, sorry, yeah, something like that. So it can't be positive. So like two positives can be there, and just so is negative, like that. So we'll still talk more about that. So the original inequality, which is this, see this inequality now, something like this. So we are looking for two values of x that will multiply together to get a value greater than 0. So for it to be greater than 0, you must be positive. Yeah, definitely this old guy must be positive. So we deal with the positive side. So we say the original inequality, is true. So we say thus, therefore the original inequality is true if -5 is less than x and x is less than 3/2. So that's the answer for this question here. Yeah, so thanks for watching. Yeah, if you haven't subscribed to my channel before, yeah, I will really appreciate it if you can click on the subscribe button. It is free. And also please share the video to as many students as you can share it to. Thank you very much for watching.